There's a popular story that radiometric dating is reliable and accurate. There are many assumptions in radiometric dating. Some methods need more than others, but all need some very basic assumptions. Let's look at just a few. Assumption 1. Samples must be homogeneous. The parent element, uranium for example, and the daughter, the element that the parent decays into, in this case lead, must be evenly distributed throughout the sample. As we saw in episode 28, Henry Fole pointed out long ago that uranium and lead both migrate in geologic time and useful ages cannot be obtained with them. Widely divergent ages can be measured from samples of the same spot. Pieces chipped from one rock can give ages from almost nothing to many millions of years. Plausible stories and excuses have been thought up to explain away the problem, but you have to want to believe them to be convinced. Assumption 2. The initial and final quantities of the parent and daughter isotopes must be known. The final quantities of those isotopes can be measured with great accuracy. The initial quantities can never be measured at all. They must be estimated, or should we say, guesstimated. Believers in radiometric dating have convinced themselves they can make good guesses. But they can never be checked, because they can never be measured. Assumption 3. There's been no contamination by other parent or daughter elements. But not only do uranium and lead migrate, as Fole pointed out, but some elements important for dating, like argon, move very quickly and easily. Again, believers find ways to convince themselves that they have the problem under control. Assumption 4. The rate of decay of the isotopes has always been the same. But as we saw in episode 25, Frederick B. Journeman noted, there has been in recent years the horrible realization that radio decay rates are not as constant as previously thought, nor are they immune to environmental influences. And this could mean that the atomic clocks are reset during some global disaster, and events which brought the Mesozoic to a close may not be 65 million years ago, but rather within the age and memory of man. Believers have stamped and performed and shrugged this off, but there are people like me who remain sceptical. Assumption 5. The samples have not been affected by external factors like heat, pressure, or chemical reactions. Almost all radiometric dating is done on volcanic rocks, but it's been found that in magma in underground magma chambers, there are very different conditions in different places in the same magma melt. Different temperatures, leading to fractional crystallization, different rates of chemical reaction, and other processes. There are very substantial variations in concentrations of elements, including parent and daughter elements, in various places in the magma chambers. The radiometric believers tend to be as dismissive, strident, and confident as the young lady we met in the previous episode. They come up with reasons for their confidence in brushing aside these assumptions. And they've been doing so for so long that they know from experience that most radiometric doubters will be cowed into silence. They loudly proclaim that nobody who knows anything about science could possibly doubt the accuracy of their dates. But let's just look at what an expert from the Max Planck Institute had to say when writing for fellow radiometric believers in a believers-only journal. The isotopic composition of lead in the rocks of the Earth as a whole has been a source of enduring mystery. Do you ever hear the radiometric believers admitting anything like that in public? One possible solution to the conundrum is the existence of a complementary reservoir of unradiogenic lead. Several candidates have been proposed, but a satisfactory solution is yet to be found. Well, why not just accept the observations at face value instead of looking for ways to ignore them? But, well, you see, they simply do not add up to the sum that would allow the bulk of the terrestrial lead isotopes to fit the standard model of an Earth built about 4.5 billion years ago. And perhaps even more surprising, he points out that one hopeful candidate in Japan, although the massif was emplaced only 23 million years ago, the unradiogenic nature of the lead contained in the body suggests that this mantle domain is at least 1 billion years old. Can you guess where the 23 million years came from? Radiometric dating. And the at least 1 billion years for the same geologic formation. Radiometric dating. Hoffman flounders about trying to find other reservoirs which might lead to a credible solution to the radiometric conundrum. But eventually he admits that nobody can find one. Now, as we've already seen, one of the key problems for the radiometric dating fiasco is the second assumption, the starting conditions. We can measure the final ratios of the isotopes, but we can never measure them at the start. C-Knight sent a link in the chat to some findings which really throw some light on the story. A lot of people have been working on a process called cold fusion since the end of World War II. In principle, the process is to enclose some electrically charged gas, called plasma, in a tube surrounded by a lot of electric coils. A powerful current is passed through the plasma. A very strong pulse of electricity is passed through the coils. This creates a very strong magnetic field. The plasma is squeezed or pinched, and it becomes so hot that the particles of the plasma clash into each other at great speed. A burst of particles comes flying out and smash into the elements strategically placed to catch them. When an element catches one of these particles, it becomes the next heaviest element on the atomic ladder. The process is known as transmutation of elements. For a long time, the process looked as if it didn't produce enough neutrons to do much atom building. But recently, some tricks have been discovered which make them produce far more. Some big, powerful, cold fusion devices have been made in various countries. A famous Polish-American physicist, Ludwig Kowalski, worked on one of the biggest in America and produced very interesting results for iron. Iron has 4 naturally occurring isotopes. 91.7% is iron 56, 2.2% is iron 57, 5.8% is iron 54, and iron 58 is very rare, only 0.3%. The isotopes were produced in the same ratios as found in nature. Kowalski moved to a cold fusion lab in Ukraine, where he worked on all kinds of elements. Quite a few did not produce the same ratios of isotopes as found in nature, sometimes more, sometimes less, but they all produced the isotopes. Now, the most trusted radiometric dating method is uranium, thorium, lead. Let's see what the Oxford reference has to say about that method. Throughout geologic time, the isotopic composition of lead in the Earth has evolved from that of primordial lead by the addition of radiogenic leads, lead 206, 207 and 208, derived from uranium and thorium decay. Lead 204 is not derived from any radioactive parent and appears to be a standard against which the other lead values can be compared. It is normally assumed that in any small part of the Earth's crust or the underlying mantle, which at the time of formation contained primordial lead, together with uranium and thorium, no radiogenic lead could have been present. With the passage of time, atoms of radiogenic lead, 206, 207 and 208, gradually replaced uranium and thorium atoms. These same people assumed that the heavy elements, like lead, were formed pretty much as they are formed in the fusion laboratory, by particles being smashed together at great speed, presumably in something like a supposed supernova explosion. So how much confidence have we that all those other isotopes were created solely by uranium and thorium decay over billions of years? The evidence that we have suggests that the majority were probably created when the lead 204 was created, in which case the contribution from uranium and thorium could be trivial. Those billions of years they confidently tell us about could disappear in a puff of smoke. And then again, the James Webb Telescope observations have trashed the last vestiges of the Big Bang and its timescale. Observations showing the Sun to be liquid, probably metallic hydrogen, trash all the ideas in astronomy which were built on stars being balls of gas. So looking to astronomy for guidance is probably not at all reliable. And recent work analysing zircon crystals, the radiometric data's favourite source of dates, throwed out on their whole story of the Earth's creation. The accepted story about the ancient Earth is that in its early stages it was a mass of hot lava which gradually cooled to form rock surfaces. It's called the Hadean era, after the mythical Greek hell. Everything was so hot that when the first rocks formed, they were changed by the heat into metamorphic rocks, which radiometric daters don't seem able to date. But they nevertheless convinced themselves that zircon crystals were unchanged by the hot conditions which metamorphosed those early rocks. So enclosures of all sorts of things, including radiometric isotopes, magnetized ion compounds, and remains of carbon from ancient life forms, were preserved intact. A very interesting paper about the fossilized magnetism in ion compounds in zircons was published by John Tarduno and his team of experts. It gives data from zircons in Australia and South Africa. Astoundingly similar data, showing that from their super reliable dates, from 3.4 billion years ago to 3.9 billion years ago, there was no tectonic activity. This means that the crust had not yet broken up into tectonic plates, but there was indeed a crust, leading to so-called stagnant lid convection. This is a bit of a problem for the confident claims by evolutionists that life began in undersea hot springs called black smokers. These springs are part of the tectonic plate story. There's another well-known paper from a group of experts at UCLA. It also deals with the reliability of acclaimed zircon crystals. Elizabeth Bell and her team of experts tell us that some of their crystals are accurately dated to 4.1 billion years. They contain, among other surprising things, carbon, which is strongly indicated to come from a biological source, So life had been around for billions of years before the tectonic plates were broken up. It also turns out that the Earth was not as hot as Hades. There appear to have been crustal rocks and free water and at least primitive life forms. Like most technical papers in the scientific journals, neither Tarduno's paper nor Bell's paper are easy for non-specialists to read. Anyone wanting to know the nitty-gritty can refer to the papers I've mentioned. For the non-experts, I'd like to read what Rebecca Boyle wrote about what these papers say in understandable language. She's the author of a book on the moon and a science writer skilled in conveying technical papers in language understandable by everyone. Things were actually looking a lot more like the modern world in some respects early on. There was water, potentially some stable crust. It's not completely out of the question that there would have been a habitable world and life of some kind, said Elizabeth Bell, a geochemist at the University of California, Los Angeles. Taken together, the latest evidence from the ancient Earth and from the Moon is painting a picture of a very different Hadean Earth, a stoutly solid, temperate, meteorite-clear and watery world, an Eden from the very beginning. Well, that sounds to me pretty much like what the Bible says things were like at the end of Creation Week, just a few thousand years ago. Well, I promised we had 2 items to look at today, so let's go to the second one. Right from episode 1, I've been pointing out that real science, science which follows the scientific method, was a wonderful, exciting and productive endeavour. But as Brian G. Wallace pointed out, in 1840 a group of Americans coined the word scientist and set up an organisation ostensibly to transform their status and image and separate themselves as professionals from those they considered amateurs. Up to that time, science had been open to anyone. Newton, Brahe and Euler were mathematicians. Lavoisier was an aristocrat. Faraday was a completely unqualified bookbinder. Joule was a businessman. It had been no problem for them to follow Bacon's scientific method, solidly based on the premise that nature carries the stamp of the Creator, because they were all Christians. But the organisation those newly named scientists set up was secular and committed to materialism, in which no divine foot in the door could be allowed. By the middle of the last century, they'd established complete control of the profession of science. Now, as we saw in episode 96, Kelvin pointed out that if you study science deep enough and long enough, it will force you to believe in God. In the 1960s and 1970s, the establishment was forced to denigrate and turn away from the scientific method because following its dictates wiped out their pet theories of evolution and vast ages of time. Other scientists have also found, after long study, that science without the scientific method has been reduced to blind submission to materialistic paradigms. And as Thomas Kuhn pointed out, scientific research has become a strenuous and devoted attempt to force nature into the conceptual boxes supplied by professional education. In the channel chat, we have some outspoken atheists who ridicule such truths and claim that today's science is the real deal. It may come as a bit of a surprise to them to watch Sabine Hossenfelder's recent YouTube video, My Dream Died. Sabine Hossenfelder is a very well-known physicist and mathematician. She features in episodes 74, 75, 81 and 86. And you may remember, from episode 74, she also features in the Freedom from Religion Foundation. So I wonder how our scoffers, who never make coherent arguments and just say I talk nonsense because I'm a creationist, will take what a star from the Freedom from Religion Foundation says. She starts off by telling us what she expected science to be like. Her expectations were based on what real science was like in the days when it followed the scientific method. And what the scientific establishment succeeds in making outsiders, like our favourite atheists, think it still is.
When I started studying at the university, my expectations were based on biographies of scientists. They wrote a lot of letters to each other, they went to conferences, they were thinkers and tinkerers, and had sometimes heated but usually respectful arguments. This is what I expected.
Then she tells us what she found when she had finished her master's degree and started research for a PhD at a physics institute in Germany. She started to find out exactly what science falsely so-called is really like.
The head of the institute made a lot of money selling textbooks. He wrote very little of these textbooks himself. Rather, he gave assignments for parts of the books to students and postdocs, which is why, in case you've ever wondered, these textbooks are so discontinuous and partly repetitive. It was also a rather rude awakening. It made me realize that this institute wasn't about knowledge discovery, it was about money making. And the more I saw of academia, the more I realized it wasn't just this particular institute and this particular professor. It was generally the case. The moment you put people into big institutions, the goal shifts from knowledge discovery to money making. Here's how this works. If a researcher gets a scholarship or research grant, then the institution gets part of that money. It's called the overhead. Technically, that's meant to pay for offices and equipment and administration, etc. But academic institutions then pay part of their staff from this overhead, so they need to keep that overhead coming. Small scholarships don't make much money, but research grants can be tens of millions of dollars, and the overhead can be anything between 15 and 50%. This is why research institutions exert loads of pressure on researchers to bring in grant money, and partly they do this by keeping the researchers on temporary contracts so that they need grants to get paid themselves, while the administrators who are paid on the overhead usually have permanent positions, but you get used to this kind of crap. And the overhead isn't even the real problem. The real problem is that the easiest way to grow in academia is to pay other people to produce papers on which you, as the grant holder, can put your name. That's how academia works. Grants pay students and postdocs to produce research papers for the grant holder, and those papers are what the supervisor then uses to apply for more grants. The result is a paper production machine in which students and postdocs are burned through to bring in money for the institution.
Carl Gauss said publish little but ripe. Today it's publish or perish, even though it's utter tripe.
Most of that money comes from your taxes. After my PhD, I applied for another scholarship and got that, and then I got a postdoc job and a grant and another job and another job and another grant and so on. And I began to understand what you need to do to get a grant or get hired. You have to work on topics that are mainstream enough, but not too mainstream. You want them to be a little bit edgy, but not too edgy. No, it needs to be something that fits into the existing machinery.
That's what Thomas Kuhn was talking about. Research is a strenuous and determined attempt to force nature into the conceptual boxes supplied by professional education.
And since most grants are 3 years or 5 years at most, it also needs to be something that can be wrapped up quickly. The more I saw of this, the more I realized this wasn't how I wanted to spend my life. The other thing that happened was that the more I saw of the foundations of physics, the more I became convinced that most of the research there wasn't based on sound scientific principles. I know this sounds wild, like I'm the crank next door on YouTube, and maybe that's what I am. But I like to think that my argument was, and still is, very academic. I never intended it to be offensive. I just explained why thinking up new particles isn't a good strategy for progress in physics, and why that had gotten an entire discipline stuck. And naive as I was, I expected physicists to think about it. I expected rational debate. But that never came. No one was interested. No one is interested. They were interested in writing more papers. And that's what they need all these particles and other wild ideas for. To write papers, to get grants, to get postdocs, to write more papers, and round it goes.
And remember the string, and amplitude-hadrons, and loop quantum gravity, decorated permutations, and all the rest of the stories for producing thousands of worthless PhDs and hundreds of thousands of valueless papers.
At this point, I'd figured out what you need to put into a grant proposal to get the money, and that's what I did. I applied for grants on research projects because it was a way to make money, not because I thought it would leave an impact in the history of science. It's not that what I did was somehow wrong. It was, and still is, totally state-of-the-art. I did what I said I'd do in the proposal. I did the calculation, I wrote the papers, I wrote my reports, and the reports were approved. Normal academic procedure. But I knew it was bullshit, just as most of the work in that area is currently bullshit, and just as most of academic research that your taxes pay for is almost certainly bullshit. The real problem I had, I think, is that I was bad at lying to myself. Of course, I tried to tell myself, and anyone who was willing to listen, that at least unofficially on the side, I do the research that I thought was worth my time, but that I couldn't get money for because it was too far off the mainstream. But that research never got done because I had to do the other stuff that I actually got paid for.
And that's what I've been pointing out for 100 episodes. What a pleasant surprise to find an insider admitting it.
When it comes to dating the age of the Earth, there's only one tool for that. It's radiometric dating. When we want to know about the deep ice cores, radiometric dating. Want to know the age of a moon? Radiometric dating. Age of the meteors? Radiometric dating. You get the picture. Until now, these dates have not favored young Earth creation. As a matter of fact, both heat problems from two of the most popular young Earth creation flood models exist trying to deal with radiometric dates that they give. That said, there are some assumptions that go into radiometric dating. There are 8 major ones that actually go into this, and until recently, none of them could be actually validated. And it's because of this, statements like this abound, and we'll not go over this because of time, but as you can see, there are problems, and they're all based on starting assumptions. So don't forget, I like radiometric dating. I think it's a tool that's one of the best ways that we can actually measure time. So that being said, we are going to focus on problem number 2, and that is when they form, what is it like? So we need to know the Proton 21 laboratories in Ukraine. That's going to be a focal point for this one. Unfortunately, this place exists in one of the worst places in the world as of right now because of a war that's breaking out. But regardless of that, they're working with cold fusion and they're creating super heavy elements using something called Z-pinch. This is where it gets really amazing because one of the scientists that is now working there, before he began working with the formations of iron. He was able to create the exact ratio and proportions of iron that we have on Earth today from an experiment. Once this formed, we compared that and we were absolutely shocked. He got a job working over at the Proton 21 laboratory, so he brought his experience and education into that. Now, the elements that have been created at that place, again, match what we see on Earth. But even more interesting is that the daughter elements formed an extremely high ratio, higher than we would ever expect. So what happened is this got the scientists into thinking, like, how are we going to utilize the high amounts of these daughter elements being produced? Like, what can we do with this? So their goal became that we're going to form high amounts of 3 particular radioactive elements: technetium 99, iodine 131, and lutetium 177, which are used for medical cancer imaging research. So that got me thinking. I'm like, wait a minute, what about the ratios for other radioactive elements that we use to date the age of the Earth? So this made me jump right over to aluminum-26, which has a short half-life of just 730,000 years. So what's it doing in such high amounts, but not just in the Milky Way galaxy, but even on Earth itself? So the scientists tried to solve this paradox that's going on, and they thought maybe the formation was via cosmic rays from the sun. But the problem is the sun couldn't have made that requirement in such a high amount in today's world in such a short amount of time. So they can throw in any rescue device that they want, but the fact is that when we look at the very formation of these things, even the aluminum-26, we're finding that the observational data matches what we see in the laboratory. It solves the paradoxes for evolution. I think that's a great thing as well. But of course, it reduces the age of the Earth to an upper limit of 740,000 years maximum because of that. And then so it made me go over and look at potassium. Lo and behold, potassium ratios are exactly the same that we see on Earth today, in the same proportions that we see on Earth today. This, again, would set the upper limit looking at potassium to just 1.25 billion years by looking at that ratio. That brings us to the next piece of evidence, which would be the lead paradox. Now, this is interesting because we have more radiogenic lead than there should be, unless, of course, you can see right here on the right side that they said unless the Earth formed 13.9 billion years ago, or 100 million years after the formation of the universe itself. So obviously this is a huge problem, and that can only be resolved through either accelerated nuclear decay or by the observational formation of these elements. Obviously, I'm going to go with that one myself. So I believe this also explains the distribution of the radioactive elements that we see on Earth today that don't make any evolutionary sense why uranium and thorium are on the crust of the Earth and not deep within the Earth, especially since they're so heavy they would have sunk to the core, or they would have already kind of been in the core, creating the power to rotate the Earth itself. But there's also other paradoxes, right? Over 50% of all radioactive materials exist just in Australia alone, as you can see from this map, and 90% of all uranium and thorium is just in Australia. So it's very disproportionate of what would ever be expected. Another analogy would be, I made all of these clocks last week that you can see right here, but they tick at different rates. There's also clocks inside of clocks that also tick at different rates. No one would have ever expected the daughter elements to form as they are today. That's probably why this is the first time you're hearing about this. So it comes down to what was expected, which was what the evolutionary community would have expected to find: uranium slowly decaying into thorium and iridium and radon. But what we actually found was more indicative of what the experiment showed, that they actually form at exactly the same time in the proportions and ratios that we see today, the exact opposite of the evolutionary prediction. So at first glance, if you were to actually see these clocks in the ground, you would think, well, they're ticking at a constant rate. So obviously, if we take that assumption and we go backwards in time, we can just reverse these clocks and it would tell us the true accurate history. While true on the surface, the most important question that we needed to ask ourselves before agreeing to that idea is, what happens if we do go backwards and we run out of history? The clocks are still giving it a time frame, but we actually can't judge it off of that. So I could say that I made these clocks last week and they do tell time perfectly. So I placed these into a computer game from the very start, or the dawn of the program, and all the NPCs using these clocks, and they came up with the same idea that we did. Like, maybe we can reverse these and find out how old something is. But they would need to read the manual to learn that I actually created these just a week ago. And I believe that the Bible is the manual for us that we use to tell us how old something is, and we go with these genealogies back in time, and it's not that old. So the same analogy applies today. I think we can tell accurate time, that they must be able to tell us accurate history. But if you're using them to tell a time about history that doesn't exist, then we have a problem. And that's exactly what happened based upon the most recent concept of evolution. I think they came in with a preconceived notion to begin with, and then they just kind of ran with that by saying, well, if we find this many daughter isotopes, then this much time must have passed. So one final analogy, I guess I could reiterate my position with, which out of all of these clocks tells better time? Well, they actually all tell really good time. But as I said, I only created them last week. So even though they all have the capacity to tell perfect time, even going backwards, we cannot use them to tell us when they formed. When these elements formed, what were their parent-to-daughter isotope ratios? That's the golden question, and today my goal is to answer that. So then we're going to conclude with, we have the formation of both non-radioactive and radioactive elements being formed in the same proportions and ratios that are on the Earth today. The radioactive elements form with both parent-to-daughter isotopes in the radioactive, or in the ratios that we find them today. We have the lead paradox, which is solved by either accelerated nuclear decay or the observations made in laboratory experiments, which shows that when lead forms, it exists as it does today, not billions of years ago. It solves the lead paradox. The new discoveries of the rocks in the mantle add further problems for the lead paradox, but it doesn't really matter for us. The new data solves these paradoxes, but the only caveat to that is it shows that the Earth is young. So if these elements formed just thousands of years ago in the exact ratio that we see them in today in the laboratory, then why assume they represent billions of years of decay? You can't. If they formed in ratios completely different than today, then sure, you have a great case against me and for eons of time passing. But since we now have observational, physical, repeatable, testable evidence on the contrary, Earth can't be old, and the evidence solves these paradoxes that exist in cosmology as well. So it seems to me that you can either accept the observational data that solves the evolutionary paradoxes or reject it, all because it confirms young Earth creation.
How dare you!
Next, let's ask ourselves, how does this fit into the biblical model, and how does this not match the evolutionary concept? Well, we would say that from Scripture, we have to look at the very beginning. We read, God created the heavens and the earth, but the earth was formless and without void. Basically, it was just a watery abyss. Then, God moved over the face of the great deep, and he created the light and the atmosphere, and separated the waters from below from the waters above. And then, on the following day, he brings forth the dry land and vegetation. From this, it is clear that God made the elements on either day 1 or day 2, since the earth and plants require these radioactive elements. So as these elements were formed, zircon crystals were also forming, trapping within them the early formation of these isotopes and their ratios that we observe forming at the Proton 21 laboratories. And when we look in the early zircon crystals today, which we are testing to determine the age of the Earth, we now know all of the lead that we find had to have come from uranium decay is not true. As stated earlier, these radioactive elements form much higher ratios of daughter elements, which would have become trapped inside the zircon crystals that rapidly decayed into lead, leading to the appearance of age. And this explains why we perceive them to be old when they are not. This alone is a nail in the coffin for deep time. But what other facts do we have to confirm this model? Well, we have recently discovered that right after the formation of these elements and they became trapped in the zircon, we have found no magnetism change whatsoever for quite some time. This means that there was no plate tectonic movement on the continents. The Bible says that all of the water was gathered into one place, and that it was during Noah's flood that the mountains of today formed. This is why it was a young Earth creationist who predicted that all of the continents once fit together into one place in the past, using Scripture. So this evidence is what we see when we look at the early crystals. It confirms Scripture and matches our predictions that we would expect to find if the biblical model was true, but not the evolutionary model, since evolution not only assumed that plate tectonics was always occurring, but it is also required for life to even arise, since their model requires geothermal vents in the ocean is where life originated. So if plate tectonics were not occurring in early Earth, then there is no arrival of life either. So this means both of their early predictions and views of the past are wrong. So the best explanation based on the evidence is that the Bible is the history book of the world, and it is reliable as such, and we can make predictions from it. And this model is the only one which can explain why the half-lives are so accurate and can be used for dating things, but they cannot tell us the age of the Earth. But they do point to one thing, that the Earth cannot be old. And this is the only model that can solve all the paradoxes that we see around us today. The chronogenesis model. Everything fits perfectly. Not only all of that, But this model solves the problem for catastrophic plate tectonics, which is a biblical creationist model that looks to accelerated nuclear decay for explaining the high amounts of helium in ancient zircon crystals and the high amounts of argon in volcanic rock. Since this leads to a catastrophic heat problem in their model, which miracles have to be invoked, this new evidence alleviates all those issues. We also see from these crystals that early Earth was not a hellish planet, as evolution has been telling us and expected to find, but rather a water-filled world full of oxygen, an Eden from the very beginning, just as the Bible has said.
My name is Mattman, and I will tell you something about heat during the flood. Is heat a problem or an answer? There are many flood models available, but they all have one problem in common. They have too much heat involved. And take a look at this statement. A sudden exposure of the mantle to 70% of the Earth's surface would release enough heat energy to boil the oceans dry several times. This is comparable to the statement, your oven has enough energy to set your curtains on fire. They are not on fire, so you don't have an oven. For comparison, the Tsar Bomba released more energy than all weapons and bombs in all wars combined, yet nobody got killed. So two things are important. It's not only the amount of energy that is involved that matters, but also the heat transport. In other words, where is the heat? So heat transport then. How do we get heat from here to there? Basically, there are only three ways to do that: heat flow, conduction and thermal radiation. If none of these is available, the heat stays where it is. Flow is like this. You have a liquid or a gas that is hot and the material moves. So this is flow and this is no flow. Conduction. Conduction is heat transport by material that is touching each other. So consider we have a hot material touching a cold material in a closed environment and the material doesn't move. After a while, all this material will have a medium temperature. So this is a good conductor and this is a bad conductor. Radiation. Radiation is heat transport by emitting light. If it's very hot, it can be red, yellow or even white. But usually we don't see it because the majority is infrared light. So this is a good radiator and this is a bad radiator. So technically it's possible to trap heat, like heat, inside the Earth. Let's take a random example. Assume we have a large piece of rock and suddenly parts of this rock gets molten for some reason. It expands a little and now let's add water to it. And let's assume the rock contains enough heat to boil all this water away. So the water then starts to boil at some point and the lava is starting to cool down. The lava sinks slowly, causing some places where hot rock goes upward. And after a while a solid layer forms on top of this molten rock and then eventually we would have a situation where a solid layer isolates the hot molten rock from the water. So we'd end up with trapped heat and still a lot of water on top. So for all the oceans to evaporate, all heat must end up in the ocean, which does not happen. You see, it's possible to touch freshly solidified lava with your shoes shortly without them catching fire. For your own safety, I highly recommend not to do this, but it is possible. So let's take a look at what would happen if continents shift quickly, exposing hot mantle material. Say the left is South America, the middle part is lava, but this is what is going to be the Atlantic Ocean, and the right is Africa. The lava is lighter than the solid rock, so it expands. Not only does this boil the ocean away there, but it also pushes the ocean away there because of the expansion. The result is that it would start to rain like crazy in colder areas, and that is on the continents. So we would have a situation where the ocean is flooding the continents and the lava has a lot of freedom to expose its heat to the sky and the universe. At the edge of the continents, the water touches the hot lava, enhancing the solidification process there. Because it solidifies, it shrinks and becomes denser than the continents, so it leaves more room for the water there. The molten lava is being squeezed out horizontally and wants to flow on top of the solidified lava. But there's water there, so it also starts to solidify. So the water is slowly pushing the molten lava towards the middle, and eventually two layers of solidified lava lean on each other, and this causes a closing seam, a closing midpoint, which we identify today as a mid-oceanic ridge. When it comes to thermal radiation, we can actually calculate how long this would take. For that we need to use the Stefan-Boltzmann law. And the result of this formula is energy per time. You get it by multiplying some constant value with the emissivity, the area and the temperature. But the temperature is in the fourth power in this formula, resulting in a tremendous nonlinear process. So the answer is in watts or joules per second, and Stefan's constant is a very small number. The emissivity is a property of the material. We're going to calculate this for basalt, which is what the oceanic floor is made of. The area is in square meters and the temperature is in kelvins. Let's give an example first. If we would have 1 cubic meter of basalt being exposed for only 1 square meter, how long would it take to solidify? And like I said, it strongly depends on the temperature. If it would cool down from 2000 Kelvin to 1900 Kelvin, it would take 399 seconds, which is about 7 minutes. From 1000 to 900 Kelvin, it takes about 2 hours. From 300 to 200 Kelvins, it takes about 20 days. And from 100 to 0, takes forever. It will never reach 0. And so this is very strongly nonlinear. Now assume we have 2 blocks of rock. They are made of the same material, they are equally thick, and they are only exposed at the top. But one of these blocks is a lot larger than the other. Which would cool down faster? If we use both the formula for heat capacity and the Stefan-Boltzmann law, we see that the area plays a role in both. More area means more heat capacity in a linear way, but more area means more thermal radiation also in a linear way. This means that in the end, for the cooling down time, area isn't relevant, it's the thickness that matters. So we can make the formulas a little bit simpler. And now we can calculate the thermal radiation for a scenario. What if the entire oceanic crust was molten at the same time? How long would it take to solidify? We use these variables. The thickness of the oceanic crust is about 7 kilometers on average, and we use temperatures that are normal for molten lava, which is a starting temperature of 1600 degrees Celsius and a solidification temperature of 1000 degrees Celsius. For this calculation, it is better to integrate the Stefan-Boltzmann law to get accurate results. Since the temperature is so high, the energy emission is huge. Remember, the temperature is in the fourth power. It takes 1 year and 150 days to solidify, so not billions of years, not millions of years, not even thousands of years, only 1.5 years, because the solidifying process itself also releases energy. This is called latent heat fusion. But also this takes only 2.3 years. So if we would melt the entire oceanic crust at once, it takes only 3.7 years to solidify using thermal radiation alone. Water enhances this solidification process, so we are actually very much in the right order of magnitude for the Genesis flood. If you see my other presentation about the solar system, you see that the evolutionary timescale for things like the moon are very far off. When a crust is solidified, it's still quite hot, about 1000 degrees Celsius. Then conduction takes over for the cooling down process. We can also calculate this. We have a formula that says that heat conduction per time is the thermal conductivity times the area times the temperature difference on both sides of the material divided by the thickness of the layer. To do this properly, we must divide the materials up in smaller layers because each of these layers have their own temperature, and thus they have their own amount of heat energy and their own conduction speed. All these layers give their energy to their neighbors, and only the top layers releases that energy to cool the whole lot down. So we start with a lot of layers that are 1000 degrees Celsius each, except for the top layer, which is a room temperature. Remember, there's water on top, which consumes a lot of heat. The layers are 50 meters thick each, and we're using a time interval of about 100 days to calculate the conductivity step by step. And we represent the temperature with colors. Red is 1000 degrees Celsius, yellow is 500 and green is 20. Here we display a layer of 7 kilometers thick. This is what it looks like after 90 years, 1000 years, 2000 years, 3000 years, 4000 years, and let's stop at 4500 years. If we are looking at the Genesis flood, it could be that this is close to the time that has passed since. There are uncertainties at when the flood year was, which is a subject for another discussion, but let's just see what the result is after 4500 years. In this scenario, all would have cooled down and we would find the maximum of 590 degrees Celsius at 4700 meters depth. Remember, we still have a lot of volcanic areas, which are in the basaltic oceanic crust, so conductivity is happening there. Since these are still hot today and only a few kilometers depth, it means these volcanic areas could not be millions of years old. This calculation shows that it can only stay hot for thousands of years. Now when it comes to heat, there are some pretty weird phenomena that come into play. One is a thermocline. You may wonder how fish could survive such a scenario. Let's say we have regions with hot water and regions with cold water. Then there are also places where the hot water flows on top of the cold water. And the hot water kills the fishes. Yes, we find a lot of dead fish in the geologic layers. And the fishes in the cold water can survive. The hot water is less dense than the cold water. This causes that hot and cold water don't mix very well. This causes a separation between hot and cold water layers, and this separation is called a thermocline. Important for fishes, but you don't need that information for the rest of this presentation. Now the next issue is power law creep. Power law creep is a process that causes rock to become viscous without increase in temperature. How do you do that? Well, let's assume we have several layers of rock, we put pressure on it, and we are going to push the top layer sideways. That is called shear stress. Then the middle layer will start to deform. In other words, it changes shape. Now if you put a gigantic shear stress on the top layer, the layer below dramatically changes shape. This process is very strongly non-linear and has to do with molecular structures breaking up and crystalline surfaces sliding on top of each other. It's very complex, but it has been tested in the laboratory. You can compare this with toothpaste. Toothpaste is solid until you put pressure on it, then it changes shape, but it will become solid again as soon as the pressure stops. This process reduces the viscosity of the rock up to 14 orders of magnitude, and thus it's very strongly non-linear. In very extreme conditions, solid rock can flow like water, without increase in temperature. The last weird phenomenon I'm going to show you is the crossover depth. We are used to magma rising up because molten material has a lower density than the same material in solid state. But it appears that molten rock is better compressible than solid rock. So if you put a lot of pressure on lava, it will eventually become more dense than the solid rock. So magma that is very deep inside the earth sinks. The point where this switches from rising to sinking is called the crossover depth. Depending on the rock type, the point where this happens is between 200 and 400 kilometers. This phenomenon has also been confirmed by multiple laboratory experiments. And very importantly, it shows that magma cannot come from deeper than 400 kilometers. The crossover depth is about here. What I think that happened is that large impact plus the crossover depth plus power law creep is catastrophic plate tectonics.
Do radioisotope ages always agree? As it turns out, absolute ages of billions of years conflicts greatly with a young age creationist worldview. After all young age creationists believe that the Earth is less than about 10,000 years old. So just how accurate is the absolute dating method? Well, according to this paper published just last year in 2023 and also presented at the 2023 International Conference on Creationism, there may be reason for caution. These researchers, they mined the National Geochronological Database looking for how often these radioisotope ages agreed with themselves. Now, if they agreed, we say that the dates are concordant. If they disagreed, we say the dates are discordant. So, for example, here is one of the records from the National Geochronological Database. Now, these coloured shapes, they represent radioisotope systems made up of isotope pairs that are used to date rocks. This one is uranium-235 to lead-207. Uranium is said to be the parent isotope and lead is said to be the daughter isotope. That is because the uranium decays away until it turns into lead. This is another system that uses potassium and argon. Now, here is yet another that uses lead to lead, but is actually based on the decay of uranium-238 and 235. Now, this is the 238 to lead-206 system. Finally, this one is rubidium to strontium. Now, the first isotope is always the parent product. The last one is always the daughter product. Now, when the same coloured shape is duplicated, it means that the same system was used twice. So, for example, there were 2 dates that used this system and only one that used this one. Now, these horizontal lines, they're error bars. And these bars, they represent the uncertainty of the age. Now, in this example, the lower bar starts at about 320 million years, and the top bar is at about 360 million years. And that means that the assumed age is about 340 million years, but also has an uncertainty of 20 million years on either side of that figure. The most important axis here is the y-axis. It shows the recorded age for each isotope pair or system in hundreds of millions of years. Now, this record is what we would call mostly concordant. So although there are some variances in the different ages, at least the overall recorded ages fall within all of the error bars. Okay, so now let's take a look at a discordant example. Notice here that the different system pairs are highly discordant. So at the top, we can see that the lead-to-lead system is concordant with the rubidium-strontium system, mutually recording ages at about 2,600,000,000 years. Now, but notice that the error bars for these two systems do not overlap with any of the other 3 systems. Next is the uranium-235 lead-207 system that is isolated, having a recorded age of about 2,400,000,000 years. And then we have these 2 systems, uranium-238 to lead-206 and thorium-232 to lead-208. The uranium to lead pair record an age of about 2,100,000,000 years, and the thorium to lead pair record an age of about 2 billion years. Notice once again that these error bars, they do not cross any of the other isotope systems. Now, as you increase the number of different systems, the amount of discordance actually increases. Interestingly, notice how concordant the same system is relative to itself. So here, for example, the same system was used to obtain 3 separate ages, but notice how concordant they all are to each other compared to how discordant the different radioisotope systems are to each other. And although it is difficult to see, there are 2 different ages using the same system here. These 2 recorded ages are so concordant that they are nearly on top of each other. Yet things get even more interesting. Back in 2005, a group of creationist scientists known as the Rate Group, they sent hundreds of rock samples to conventional labs for dating. They wanted to know if indeed radioisotope ages were concordant or discordant. Now, this graph is my simplified version of their research. The rock unit is given on the left with its age as found in the scientific literature given in the next column. The dating method is shown next, then the number of samples. The last 4 columns show the ages as determined by the conventional labs for the samples that the creationist scientists had sent to them. Now, the creationist scientists organized things so that the same rock unit was dated using 4 different methods. They are potassium argon, rubidium strontium, samarium neodymium, and lead to lead. Now, this latter method, however, depends on the uranium 238, 235 to lead 206, 207 systems. I did not include the error bars, and the ages in red have enough error, but the numbers may not be statistically significant. Now, as it turns out, the dates were mostly discordant. Notice that the age in the second column that comes from the literature often disagreed with the most recent ages obtained by the rate research. Now, that alone is really, really interesting. Now, as we have seen, it was also demonstrated by this latest research in 2023. But here's what's really interesting. The 4 different isotope systems in the last 4 columns are all in order with the lowest atomic mass first and the highest atomic mass last. So potassium has an atomic mass of 40, rubidium 87, samarium 147, and the lead-to-lead system, which is dependent on both uranium 238 and 235, would give us an average mass of about 236.5. Now have a look at the rock units, starting with the Brahm amphibolites, and look at the dates going from the left to the right. The rate group discovered that much of the time, but not all of the time, the lightest atomic mass system dated younger than the heavier systems. Now, this also occurs with the Elves Chasm granodiorite. Other rock units only generally had this trend. So, for example, the Gardines basalt and the Somerset Dam layered mafic intrusion. Certainly interesting, don't you think? Well, in this latest paper from 2023, and with the rate group's research in mind, similar results were also obtained. And this is how they summed up their observations on this general pattern of older ages for heavier isotope systems. We also found a systematic pattern in radioisotope discordances, somewhat similar to the pattern identified previously by the rate radioisotopes and the age of the Earth group. Rate also reported that within alpha or beta decaying methods, the heavier isotope tended to yield older ages. In our study, we found the same pattern. So what does all of this mean? Well, I think the first thing we must realize is that this new research is still preliminary. For example, no attempt was made to distinguish model ages from mineral isochron ages from concordia ages. There was also the application of a simple concordance-discordance metric. Either the age was or wasn't discordant. Future research will undoubtedly need to improve these and other methodological and data shortcomings. So please don't think that the young age creationist absolute dating problem is solved. It isn't. Now, having said that, however, I do think that the rate group and now these other young age creationist researchers, I think they're onto something. Not only do these data support the notion that radioisotope discordance is real, it is alarmingly so. Now, more importantly, however, is the observation that heavier isotopes may actually date older than lighter isotopes.